Hey guys, so I'm currently in Delft, as you can see, and I'm going to be spending the whole day here. I'm going to take this chance to meet up with a couple of old friends from my bachelor, because as you might know, I did my 3-year Bachelor of Aerospace Engineering here in Delft. And later on, I'm going to also meet up with a few people from the driverless team in Delft, which is where I did my gap year. And I'm going to take this chance to take you along with me and learn a bit more about what these friends are doing here for their masters. And since they're doing topics related to robotics, I'm also going to ask them a few questions about what the robotics masters is like here in Delft. And hopefully that should be useful also for you guys. So I hope you enjoy, and I'll see you in a bit.
This is the main lab where there is the assembly of drones and testing, and where all master students work together.
Yeah.
You can see there is a bit much of action. This is like an overactuated flying wing, which is part of the research project. Here you have soldering stations where you're assembling several other drones for flying wings. We got a few 3D printers also here, where they're always busy. Now, it's a miracle that they're all free. Usually they're always busy day and night. 3D printing, of course, is very important. Yeah, those are previous projects. Those are not being used anymore. This is a new version of the actuated quad plane.
This one, okay.
Evolved to this.
Okay. And is this like just purely a research platform, or is it being like done in collaboration with like some commercial purpose in mind or something?
No, this is a purely a research platform. It's a PhD thesis.
Okay.
So that's what it is. It really looks cool while flying.
Yeah.
So, because it can change its orientation, its attitude by staying in the same place.
Right.
So
it's actually, so it can, like, what's the degree of freedom here? It can rotate like this. Oh.
Yeah.
Okay.
Nice. Full 180 degrees, and I think this is also full 180.
Nice.
Yeah.
It's actually my favorite.
He's my favorite drone as well. And we have a manufacturing facility in the back room.
Yeah.
Where basically right now we have upgraded a new wire cutter for foam cutting mostly.
Yeah.
So here there is all the assembly, all the gluing. So this is the new wire cutter, new controller, and then there is also a CNC machine that we use for cutting of carbon plates. So basically we can manufacture everything. Many master theses are actually involve actually the manufacturing of a drone from the ground up.
Yeah.
So it really involves the whole process of manufacturing, studying the design, getting hands on the machines, and then actually design the controller, write the controller. So it takes
wow. Okay, then I understand why you need 9 months for that.
And you have like all the glues and everything to basically assemble. So in this room you can basically assemble everything and build your own drone.
Wow.
And this is usually the case for students and especially PhDs.
What about like the electronics and like parts like propellers, motors and stuff?
Propellers, motors, they get assembled and tested. They can get also tested here. There is a test box. There is a testing platform where you can put on the motor and then derive all the dynamics and how the motor is performing with the propeller on. You can also you have 2 soldering stations, 3 actually, soldering station, and in this lab where you saw before. And you can do basically the whole assembly of electronic components. And then when you go to testing, you actually go to the aircraft hall where there is a secure environment where you can fly without the risk of crashing the drone or damaging any parts.
Okay. Okay, cool.
So this is what we are going right now. So here is where once you have manufactured your drone, you want to test it in a safe environment. This is the Cyber Zoo. The Cyber Zoo has a fake grass floor where you basically can limit the damage in case you hit the ground. In addition to that, you also have a rope where that can assist you in flying without having trouble whether or not the drone falls or not. Now you see that there is like a lot of patterns on the ground. This is because they are testing optical flow algorithms in descent, and so it's mostly that. And the whole zoo has also an OptiTrack system, which tracks
the pose
provides a perfect state estimation up to a few millimeters. So it's also great to test the controls without having to worry about the noise of sensors. And then here there is a new facility.
Oh, sick.
This facility is dedicated to the projects that are being carried out with the Dutch Navy. This is one of the products. That is the Nether drone, which basically has offshore purpose machine. And it is fueled with hydrogen. And so the bulky fuselage is like that because inside there is an hydrogen tank, gaseous hydrogen tank, which propels the drone and gives an endurance of around 3 hours offshore. So this is being currently the solutions for offshore surveillance for the Navy. And there are new projects going on, new designs, but this is basically the workshop where the focus is on that objective.
So novel designs, novel topologies
novel
of
designs for offshore navigation and surveillance. That's basically what it is.
Cool. So I just came back from the aerospace faculty, and I'm walking back to campus now. Actually walking through a street where I used to live, here in Corvezeestraat. And now I'm heading to the mechanical engineering faculty, which is where I'm going to meet Mees, who also studies robotics, but at a different faculty. So yeah, I'll see you there.
So here I think we're seeing arguably the largest robots we have here at TU Delft. So these are some of the autonomous cars. We have the Toyota Prius and the BMW. I think especially a lot of work's happening on the Toyota, but on
So do they like drive them around the city, or?
I think there's one, they have recorded a data set where they drove around the Delft city center, and you could see the classifications of pedestrians and cyclists. Because of course, driving autonomously in the Netherlands is quite challenging with all the cyclists. I mean,
No, I totally get it. Even for a human, it's freaking hard.
Yeah, exactly.
So they also, so they do a lot of like research on pedestrian behavior prediction and like cyclist prediction, right?
Yeah, I think so. Yeah, it's not really my field, but I think they also focus on where the driver is focusing at his eyes. So I think we can see it.
Yeah,
so there are a lot of cameras focused on
driver monitoring.
The driver itself. Yeah, so they track the eyes of the driver to see where his focus on.
So basically right now I'm doing the finishing my thesis. In addition to that, I'm also helping students in a course called Autonomous Flight for Micro-Air Vehicles, which teaches students to navigate through vision-based algorithms in an unknown environment with obstacles. And that's a 3-month course where you just help them understanding the autopilot. Here at TU Delft, the autopilot being used mostly is Paparazzi, which is being used for 20 years now. And maybe one day they will move to ROS, we'll see, never too late. The master program that I'm doing right now is control and simulation. It involves basically the understanding and development of conventional or intelligent control algorithms. It specializes mostly in drones, so the MAVLAB, the Micro-Air Vehicle Laboratory, is really involved with students of this type of master. And it also yeah, the MAVLAB, basically it's called micro air vehicle, but they do many things, many projects. Project that span with collaboration with the Navy for big drones for offshore navigation, but also bio-inspired vehicles. Delft is pretty famous for the Delft Fly, which basically imitates the Dragonfly style, let's say.
Well, so my name is Mees. I'm 25 years old, and now I study robotics. I did a bachelor's in aerospace, just like you, actually. Yeah, and then we did the dream team together, working on autonomous racing.
I remember.
Yeah. So that's how we met.
Yeah.
And now we're both doing robotics at different universities. So this is the Cognitive Robotics Lab, and since 2020 they started the Masters in Robotics, which basically merges a lot of different tracks which are related to robotics. They have now merged those into one. For example, Hug Engineering, so which is more oriented towards autonomous driving. They had one on biorobotics and one on haptic interfaces that has now all been merged into one single master's, basically, and that's what I'm doing. You know, at Aerospace, we have our bachelor's end project, which is 10 weeks, and with a group of 10 you design an airplane or a space system or something. And at that point I thought to myself, is this really something that I want to continue with? In general, I really liked aerospace, but I thought, is this really what I want? So then I decided to join the dream team that we did, Formula Student Team Delft, to work on autonomous cars, because I was really interested more in the software side and also applying what I learned so far. And that basically essentially was eye-opening to the field of robotics and how it can be. And then I was lucky enough that exactly the year after a brand new Masters in Robotics started at TU Delft. Because I think if I didn't do the dream team as a gap year, I probably would have ended either up here at Systems and Control or at Aerospace doing probably control and simulation or something. So but those are they're not exactly robotics. They're of course more control related. But in the end, I'm very happy I ended up at this Masters.
So the program here is structured to be nominally concluded in 2 years. You do first, you have from 3 to 4 quarters of 2 months and a half each, where you have to follow predefined courses and elective courses. So a percentage of that is already given, and you cannot refuse to do it. But then there are also other courses which are you can choose them. You must get them approved. They must be coherent with your path. But of course, you can decide to explore different paths as well. And then you must conclude at least a 3 months internship that can also be extended to 1 year if there are cases of that. In addition to that, at the end you need to find basically a research lab within the faculty where you can get a thesis proposal and start investigating to the thesis. For the thesis, usually nominal time is around 9 months. Because it includes 2 months almost of heavy literature investigation, because you want to be sure that what you're gonna do is never been done, and you are actually solving a problem. So that takes some time, and is actually a course that is graded on the side. So you do that, and then you finish your thesis approximately 9 months. That should add up to 2 years most of the time.
But typically, on average, do you think the length is?
I think the average is higher. If I managed to finish in 2 years, is because I basically did the internship during the summer and all the courses in 3 quarters. So it's really tight. But if you want to take it within a reasonable time, so taking 4 quarters. And then doing an internship when you started a new academic year by taking your summer, and then you want to start a thesis and take it to 10, 12 months, probably in 3 years. That's more suitable time, probably.
So I finished the first years of my master's. So the first years of my master's is just courses, 60 ECTS worth of courses. Then I did an internship for 15 ECTS in Germany, and now I started my literature research in February. And the thesis in total is 45 ECTS, which 10 of which is for the literature research, and then 35 is for the actual thesis. And then.
So how long does the master thesis usually take?
I think 45 ECTS should be 9 months, I think, but it's not uncommon that it takes longer, to a year maybe. But it's also, of course, how ambitious you are. I mean, do you want to get a super good grade, or I guess it's also depends on the student itself.
Right.
The courses that I've taken are mostly related to conventional control for the courses that you must follow. Some of them are also, for example, one of them was a stochastic analysis that is required in every type of controller. And then when you decide to go for an elective, you can decide from for example, more navigation-based courses, more artificial intelligence-driven courses, or more conventional control courses. Personally, what I did was knowledge-based control systems. Then I also wanted to put hands on hardware, real devices, so I did the course Micro Air Vehicles, which basically you are given a drone to work with, and you learn indeed more than developing solutions for autonomous flight. You learn actually to implement the solution for autonomous flight, which is always required. It's part of the job. And in addition to that, I did also programming courses, most of them.
Okay.
There is a nice programming course of C++ that was not in this faculty. I did it in computer science, and there probably is a fourth. I work. There is the MAVLAB offers also a master student course that gives 4 credits, and that is basically a project where you help a researcher within the MAVLAB. So my project was to implement an optical flow sensor inside a drone that had to fly at a long distance from the pilot. And basically, when there was a loss of GPS, you wanted to still to keep like a hovering position without accounting for the delay of the pilot to reach the drone. Mm-hmm. And so I implemented this sensor, and basically in the MAVLAB you have to work from the selection of the sensor to the implementation of the actual driver of the sensor within the autopilot, to the implementation of the data that you get from the sensor into the state estimation filter. So it took all the time, and then there are many tests outdoor, since most of these tests must be taken outdoor. You go outdoor, you experience also the fact of testing in windy environments. So it basically takes all of it, and it's not really advertised because there are not many spots. But if you know that you can, that you have this opportunity, definitely contact them, and this opportunity is available. It's just not advertised. So
you have the first half of the year is just obligatory courses only, like programming and ROS, robot dynamics and control, and machine learning courses. Those are all first quarter. In the second quarter you have machine vision, you have a course on motion planning, and a course on haptics and human-robot interaction. And those are your obligatory courses, and you also have a project course in the fourth quarter. And between these and quarter 3 and quarter 4, you can basically pick your own electives.
Okay.
So my electives were more focused on controls and optimization, which is the direction I actually went with my thesis.
The main languages used to complete this course, the whole year, and the other projects, I think are mostly C, because C is the main language on which the autopilot is developed. Also C++, indeed, it's very important, but since the autopilot needs to be extremely optimized, usually you build your own function within C instead of using packages. Python usually on flight is not an option. You use it for post-processing of data. There are many tools within the MAVLAB. They probably prefer for post-processing more MATLAB, for which we have many tools, and so it's really easy. And the logger files the logs that you obtain from the drones usually are more friendly for MATLAB environment. But I also use Python when I wanted to go a bit more into depth with data observation and processing. And so mostly I would say C, understanding C, and also understanding the structure of an autopilot is very important, because at the end, okay, we are using a different autopilot than, for example, ROS or Pix4. But all of them have the same reasoning behind it. So you start from an airframe, then you inside the airframe you have several modules. These modules communicate through each other. So also I think it's not time lost to work on paparazzi heavily, understand paparazzi heavily, because that translates also to understanding the other autopilots very well. So
in terms of programming, you mostly already in first quarter you learn ROS and C++ as well. So I think that's really good. But for me, I already used these things both during our Dream Team year. So for me, those weren't exactly new. But I think it's really good that you already learn these things right from the start. Because I think almost everyone uses these, at least ROS, during their thesis, or let's say a lot of students.
And those are mandatory courses?
Robot programming in ROS is mandatory.
And C++?
No, I did it as an elective, but it's also included in the ROS programming course. So
cool. Yeah, at ETH that's not the case. And a lot of students, like Patty, I know at least, she's wanted to learn C++ for a while. And there wasn't something like that. I mean, there is the ROS course you can do optionally, but that's in the spring semester. And then there's no course on like just C++. It's like maybe a computer graphics course or a course on computational models of motion that uses C++, but it's not very clear or obvious that that's the case.
The thesis is about the improvement of a controller that is heavily researched here at TU Delft, which is an incremental nonlinear dynamic inversion controller, and I'm trying to add state compensation terms that can correct for, let's say, aerodynamic effects and this and that. Usually, I know from my department, from my faculty, that the thesis topic, the idea of doing a thesis into a company for the control and simulation department is not really a great idea. There is a lot of research here, a lot of cutting-edge technology is being developed, and they want to follow more the student and be sure that what he delivers is good quality. Most of the time, the thesis within the MAVLAB and the control and simulation department get published. The request, the deliverable indeed is not a book that you usually do for the thesis. Usually, it's only the paper. So that's the final deliverable. That's why it's so important for them to have actually material that you can publish eventually. So they really encourage you to stay there and to work with professors that are researching within the department rather than go to an industry.
My thesis is about efficient locomotion of quadruped robots. Actually, this is the first time I'm seeing this thing as well, so I'm quite excited. But the idea is that using springs, elastic elements, which you can see them here and here as well, that the idea is that we can make it walk more efficiently, which is more akin to actually how we walk using our elastic tendons and muscles. So we save a lot of energy during walking and running. And actually, common robots like Spot or Animal, they don't regenerate or preserve any energy during locomotion. Energy is just simply lost on impact. And the idea is that we can preserve some of this energy to basically walk more efficient.
Cool.
That's the idea.
the workload in the faculty is really, I think it's subjective and based on first in how much amount of time you want to finish.
Yeah.
If the objective is to finish within the nominal time, which is 2 years, the workload will be constant and probably intense because you want to squash courses together. You want to give up time available to find the internship, go to the internship and do it. And it also, I think in general, the thesis topics for this track and for other tracks, for most of the tracks within the TU Delft, they are heavily involved into real applications, so you don't see really theses that don't have results in real life. And that, of course, organizing the testing, facing real-world challenges that makes the time and the effort definitely higher, and therefore I would say if you think about finishing it in 3 years and you spread it in a smart way, you can have a decent workload. But definitely it's going to be higher if you decide to do it in 2 years.
My life last year is quite different to a student doing his master's right now, because obviously because of COVID. I started my master's during COVID. So back then what my day looked like is I got up at let's say somewhere between 8 and 9. And then usually sometimes I had a morning lecture in the morning. And then I watched the lecture online, and afterwards I had to work on an assignment. Yeah, there are definitely a lot of assignments in this master's. Especially in the first quarter, we had multiple deadlines each week. So the first quarter was actually quite intense. The second and third were quite a bit better. But yeah, so I worked mostly on my assignments when I was not having a lecture. And I think that was basically most of my first year. But I would say it was quite intense. The workload is pretty high, and maybe it's also a result of the masters being so new. So they still have to figure out how they should adjust the workload.
Mm-hmm.
Regarding the internship topic, usually there is an internship office which manages the applications and approves the internship ideas that will be found. Sometimes maybe an internship is not really into the topic, so can get refused, or the company has some problems and they can figure out whether this company has some problems, and so they try to protect you in that sense. The internship office also gives a list of possible applications. These possible applications usually include Airbus, Lockheed Martin, and other, heavily related to control. But you can also access internships that are being offered to other master tracks. Mm-hmm. Personally, I was involved within the Navy project of the MAVLAB, so the Navy asked me if I could work for them during a bit of time together with another team. We decided to go for to develop a landing system for the drone that they were developing in the MAVLAB. We already had knowledge of the drone, so we could really start developing and implement from day one. So that involved, basically at the end was my internship. But I know from people that went to, most of my colleagues, they go to drone-related companies. So Switzerland is also a nice environment. In the Netherlands, it's full of startups and interesting companies that work with drones and develop drones. We have, for example, AV. Many people go to AV. There is the Unmanned Valley, which is an incubator of drone startups that is located close to Leiden, and that offers many opportunities, and many people go there as well. I think Delft is a bit rare, I think. There are opportunities, but it's a small environment, of course, and then you want to explore also outside. So many people actually relocate, and even if it's for 3 months, it's usually worth it. So yeah, many people do that. Regarding startups that develop are because of a spin-off of this faculty especially, and of this department of robotics, which is control and simulation. Well, there are many. For example, here in TU Delft there is an innovation hub which offers office spaces to several startups that work into that. One of them, for example, is Flapper Drones. Flapper Drones is a startup that is directly a spin-off from the project that involved the Delphi. So now this drone is being developed in a more commercial way for entertainment, but also navigation in small environments. It's also really pleasant to watch this kind of drones, respect to like a quadrotor, which is noisy and scary. Therefore, it can find many applications also in the industry, not only entertainment. So it's going pretty well. Another drone company, robotics company that's being developed that is now working actively is PATS. PATS develops indoor solutions for basically counter moths' presence into greenhouses, and they do it basically by using the propellers. So intercepting the moths and using the propeller to basically get rid of it, and so it's kind of working right now. And that's the advantage of that is that you don't have to get rid of the moths with chemicals, and so that basically removes the needs of chemicals and expenses and everything else. So that's another one. On a more deep control side, there is also Fusion Engineering, which is developing autopilots, new autopilots for applications that require heavy robustness and redundancy. So they are developing basically a new autopilot for that.
I have one company, Vizier, they're working on computer vision. So that came out of a research challenge, I think, the Amazon Picking Challenge, which a team from Delft actually won. I think it was in 2015 or maybe earlier, I don't know. But they started a company and now they're working on computer vision to detect parcels, basically. To detect the orientation of these parcels, and then a robot can pick it up and place it from one place to the next.
In what context? In like a warehouse or something?
Yeah, warehouse, logistics.
During my master, I did the 2 TAs position, one for aerodynamic course and for the micro-air vehicle course. I think it's heavily possible. The TA usually requires 8 hours a week, which you can compress pretty nicely, spread during your time. They're also in the masters. You are also very flexible. Professor usually let you do things without a lot of guidance, of course, so you are very autonomous as soon as you deliver your 8 hours and basically with a quality work, it's fine. So I would really recommend it. It's also a good pay for what you do, and you also learn a lot. In a few months, I will be joining Parrot Drones, which is a company in Paris that develops firstly in the past commercial drones and now more targeted for the industry applications. And I think I really like the idea of going to Parrot Drones because in the MAVLAB there is a heavy collaboration with Parrot already. We use Parrot drones, we know the quality of what they do, so it's really great way to continue to start, let's say, going into the industry. And my role there will be to develop obstacle avoidance algorithms for outdoor navigation. More than the recognition part, which is for others. My part is going to be more on the trajectory optimization once the obstacle has been localized. So that's going to be basically the starting point.
It's still something I consider doing a PhD. But yeah, the thing is, do I want to do it in Delft? I mean, I'm already here for 7 years. Do I want to be here for another 4 years? That's something I'm not really sure about. But it does really interest me because right now I'm studying legged robots and I find it really interesting and amazing what these robots can do. But there are simply not a lot of places where you can work on them, especially in industry. Mostly it's still research, of course. So yeah, it could be, but I'm not sure if I would want to stay in Delft for that reason. I think I would mostly likely go to industry, or at least I don't really want to pursue a career in academics. So far, that's not my plan. Yeah, for example, you have Lely in the Netherlands. They're a very big robotics company, and they do a lot of stuff, especially for agriculture. You have Lightyear in the Netherlands, which is also really cool. I think nowadays they're a scale up. They build solar-powered electric cars. And I think they're also investigating autonomous driving nowadays. So that could be really interesting. What else do you have? You have a few big guys that are now big tech companies that are now settling in Amsterdam. For example, Locus Robotics is a very big company in autonomous mobile robots for logistics.